Welcome back. This is section 2.1.2, converting logic statements to English. The first compound statement is if then. The way you represent is if P, then Q. The statement before, so the P is called antecedent and the Q is called consequent. Okay, if antecedent, then consequent. Let's take an example. So let P be a statement which says n is divisible by 6. Let Q be another statement, n is even. So how many ways can you say this? If n is divisible by 6, comma, then n is even. That means P, if P, then Q. Any integer n, comma, which is divisible by 6 must be an even. Since n is divisible by 6, it is even. In order for an integer n to be even, it is sufficient that it is divisible by 6. So most of your homeworks, you'll see something that uses the word sufficient or necessary, or even you'll see something that says any comma n, which is so always make sure you have these sentences with you so you know that instead of saying if n is divisible by q, then n is even. These are all different ways of saying that particular compound statement. Now the next one is if and only if. So if I have P with double arrows, that is if and only if. And how do I represent that? The statement formed by using the connective if and only if is called a biconditional. The one above is just conditional statement. This is a biconditional statement. And we use a symbol which has double arrows. Okay? So P is true if and only if Q is true. That's one way of saying. Or you can say for P to be true, it is necessary and sufficient that Q is true. Now you might ask me, Miss, why so many ways? This is just the way it when it comes to logic, this is just the way it's done. You have to use this terminology in order for that statement, that compound statement to be true. Now let's take a look at this example. N is divisible by 2. That's a statement P. N is even. That's the statement Q. If I have to say, I'll say if N is divisible by 2, sorry, if and only if n is divisible by 2, then n is an even number. That's one way of saying it, correct? But another way of saying it is an integer n is divisible by 2 if and only if it's even. In order for an integer n to be even, it is necessary and sufficient for it to be divisible by 2. So please keep in mind, it says here in order for an integer n to be even, that means the Q statement is coming first. It is necessary and sufficient for it to be divisible by 2. That means the P statement is coming next. Now this will be very confusing, but let's go ahead and take a look at some examples so this makes our life much more easier. All right. So let's take a look at this example here. It says let P, so the equation, so the statement, sorry, not equation, the statement P says coral is a not fragile organism. Let Q, so the statement Q says we should drill offshore oil. So P stands for coral is not a fragile organism. And Q, we should drill offshore oil. Now he says represent the statement. If coral is a fragile organism, so this is simply the opposite. Here it says not, and here it says coral is. That means it's the opposite, so not P. So if not P, then let's see the next statement. We should not drill offshore oil. Wait a minute. Q stands for we should drill offshore oil. That means this is the negation, not Q. If not P, then not Q. And the only option is this one. All right, let's take a look at the next one. Let's go ahead and take a look at this problem here. So let P be the car is not, oops. Let P be the car is not black, and let Q be the car is not red. What statement is equivalent to the symbolic form of not P? So P is the car is not black. So not P means the car is black. Q is the car is not red. So once I know this, I'm only looking for these keywords. The car is black. The first one says the car is not black. So this cannot be my option. The second one says the car is red. But what am I looking for? Car is not red. Let's see. The car to be black, yes. And the car must not be red, yes. Let me see another one. Car to be red. No, I want the car not to be red. So definitely not this option as well. So my only option is in order for the car to be red, in order for the car to be black, the car must not be red, which does make sense. All right, let's look at the next problem. All right, let's take a look here. Let me increase this one. Oh, whoa, that's too big. All right, let's go ahead and take a look at this one here. So let P be Jill will climb Himalayas, and let Q, Jill will hire a Sherpa. So I think Sherpa, yeah, Sherpa, yeah. What statement is equivalent to the symbol P then Q? So keep in mind there's no negation here. Everything is simple. So my first step is to take away everything that is negating. Won't hire, nope. Won't hire, nope. Won't climb, nope. My only option that I'm left with is Jill will hire a Sherpa is necessary for Jill will climb Himalayas. There you go. So keep it simple all the time. Let's take a look at the next one. Let's take a look at this problem here. Write a statement, all runners wear shoe, in symbolic form, where P is a statement, I am not a runner, and Q is a statement, I don't wear shoes. So here we want something that says all runners wear shoe. So all runners wear shoe. So P is saying, I am not a runner. So we want not P. And Q is saying, I don't wear shoes, so we want not Q. So we definitely want not P. We definitely want not Q because we want everybody to be a runner and wear shoe. So definitely not this. Let's see. P and P, so you see how they mislead you? This is good, but this should also be a negation. Do you see that? Both should be negation. So boom, boom, boom. My only option is not P, not Q. You see how simple it is? Always keep it simple and delete the ones that are not your options. Let's look at this problem here. Let P be, she is a member of a club, and QB, she pays her dues. Which of the following is biconditional? Remember biconditional, the keyword is if and only if. Okay, so this is not my option because it says if then. She is a member of the club or, I don't need a or. Member of a club and, I don't need a and. What am I left with? If and only if. So this is my option. Always keep it simple. Let's take a look at this problem. Let P be x plus 3 is 11. Let Q be x is equal to 8. Which of the following statements best represents P if and only if Q? I like it when it's simple. So if, then, no, because it's biconditional. I need to have if and only if. Definitely not and. Again, if and then, that's a no-no. What am I left with? If and only if. Always keep it simple. Let's look at the next question here. P, there is ice. Q, temperature is above 32. Which of the following statements represent P, not Q? Not Q is temperature is not above 32. So I'm looking for the keywords. There is ice and it's not above. Okay, so definitely not this because this says there is no ice and temperature is not above 32. So definitely not this one. Boom. There is ice. There is ice only if the temperature is not. Yeah, this kind of looks good. There is ice and not above. Let's keep it there. There is ice and temperature is above. No, temperature should not be above. There is ice. What is the keyword here? If and only if. My keyword is if and only if. So yes, there is ice. Yes, it's not above 32. So definitely my answer is this. So always look for the keywords. Let's take a look at the next problem. Let P be the statement. So what's the statement here? P is I think. Q be the statement I am. Which of the following statements either I don't think or I am? So this is definitely a Q. Or is a V. I don't think. So P is I think. I don't think is not P. So my only option is, there you go. Again, keep it simple. Let's go ahead and take a look at this one here. Let P be the statement, time is money. That's true. Let Q be the statement, money is freedom. That is absolutely true. So which statement represents time is money and is inverted V, money is freedom. So plop, P, money is freedom is Q. My only option is P and Q. Again, please make sure you review these symbols where V stands for or and inverted V stands for and. Always have them written down so you're not confused. Let P be the statement, Labor Day is a holiday. Q be the statement, we do work on Labor Day. Which of the following represents Labor Day is a holiday, that is P, and we do not work on Labor Day. So Q is we work on Labor Day. The opposite is negation of Q. And the only one that satisfies is da. There you go. Again, always keep in mind, you write down as you read. Labor Day is holiday. P and is inverted V. We do not work, opposite, not Q. All right? Let's take a look at this problem here. It says, let P be the statement, the baby is tired. And let Q be the statement, he won't fall asleep in the car. What statement is represented by the symbol not P? Not P is the baby is not tired. So I'm looking for the keyword baby not tired. And Q is, yeah, he won't fall asleep. So that's good. The first one says the baby is tired. Nah, I don't want it. This one says the baby is not tired. Okay, I'm going to come back to you. The baby is tired. Nah, the baby is not tired. Yes. And what does it say? He won't fall asleep. Here it says he will fall asleep. So this is not my option. My only option is the baby is not tired and he won't fall asleep in the car. Again, if you have any questions, please make sure you take a screenshot of the problem, email me, contact me through Teams as well. All right, hope this helps.